In today's video, a flagship from a top-tier brand and a speaker project you've all been asking for. So, it would appear that Bambu Lab has taken notice of the shenanigans here on the channel, and as a way of saying hello, I've been sent the proverbial gift basket of goodies. Strictly speaking, this is all for the purpose of getting me acquainted with the Bambu Lab ecosystem, and I wasn't even asked to produce a review. So, you're watching one anyhow because we all know that my reviews aren't really reviews. I'm not even gonna tell you the build volume or anything. These are mostly just DIY project videos and the gear is mostly just circumstantial. Case in point, with the circumstances being that I have this Bambu Lab X1-Carbon sitting on the bench, may as well run it through a feature build. So, once the machine is all done getting its bearings, we can start running through the sample PLA, as the spools are reusable and we'll need them for later. Here's the pre-sliced 3D benchy, and before it ever gets to laying anything down, the machine runs through this whole elaborate routine, almost like a martial artist gathering his chi, long before eventually undoing the trip to Home Depot. But the results speak for themselves. Even at speed, this is probably my best rendition of the 3D benchy yet. Up next, I want something to collect the bits of filament being expelled through this opening, and just to keep it simple, I designed a container that latches onto the back with some of these tiny Harbor Freight neodymium magnets. So, that literally just sticks on, and given that there's still some filament left on the spool, here's some more random stuff for the house. There was also a half spool of green PLA, which I turned into a few more of these giant thumbtacks for Sophie. Anyhow, if there's one thing that I've been able to confirm thus far, it's that the machine performs every bit as well as all the surface level reviews would insist ad nauseum. This, however, is child's play, so let's actually put the machine to work. And the one project that's been requested, more so than any other, is a portable Bluetooth speaker. That being said, if there was ever a chunk of portable audio that I could think back to with any degree of fondness, it would have been my vintage 2000 JVC RV-B550 boombox. No woofers, no tweeters, just a pair of extended range drivers with blue LEDs in the dust caps and a 24-watt amplifier. I had even wished that there was a version without the tape deck or the CD player, just a modest sounding little cylinder with an auxiliary input. Well, fast forward some 20 odd years to where Bluetooth is ubiquitous, blue LEDs aren't, and companies like Bambu Lab exist to facilitate what is essentially spare bedroom manufacturing, and we should be able to replicate the experience with just a couple of these 4-inch mid-woofers from Dayton Audio. Hardly the ideal stand-in, given that the original boombox also played down to 50 Hz, but with literally every better suited extended range driver inadvertently sold out right as I was planning the project, we'll just make these $30 Daytons do the impossible. Introducing Jammer Mini. With the two RS100P 4-inch drivers as the only active components in this twin bass reflex arrangement, the system should still reach 50 Hz by way of two side-firing 6.5-inch passive radiators. Around the back, there is a dedicated amplifier/battery compartment with hidden channels leading to the outer grills for some optional illumination, and the whole thing comes together by way of a tongue and groove joint with a separator baffle resting on an inner ledge. So, that's the graphics out of the way, which also means that I'll want to get these spools loaded up with some filament. And just for the sake of preparedness, I also picked up a few extras. This will be my first time printing with Bambu Lab's High Flow PETG, which comes as a refill that you transfer onto an existing spool, though you still have the option to buy it already set up like this. There's even an RFID tag for the AMS to read, thus identifying what's being fed down to the extruder. Nevertheless, before any of that, I am also forewarned that this new high flow stuff can print like crap until you dry it out, so let me just scooch this over to make room for a filament dehydrator and throw these in there for a little while. I was also encouraged to try some of this new support material, formulated to work with both PLA and PETG. So that's going in there along with the two colors, and now we are ready to print, starting with the two end grills. This is a single color piece, however, with supports it still makes thorough use of the AMS. And given the quality of what I'm seeing, I am genuinely dumbfounded by the sheer fact that nothing has yet gone wrong. Though, just as I say that, reality returns from a smoke break and we have a layer shift. This seems quite the oddity given how well the machine handled all the single material prints, but with no indication as to what the nozzle crashed into, I'm literally just going to reprint, and whatever happened last time didn't happen this time. The piece looks damn near flawless, save for the small liberty that the slicer took with my design in setting the protective crossbar, which inadvertently demonstrates just how well this new support material performs as a foundation for a bridge, especially when the underside is about as smooth as the top side. So let's just fire off a second one, this time with Sophie getting to peel the interface layer. And while I'm at it, let's also check on the poop collector, which I am now emptying for the very first time. This gives me some idea as to how frequently I'll want to get after it. Up next, the left section. This is a 4-day print, and while it's only projected to run through about 2.5 kilos of filament, there is also no fewer than 2013 filament swaps across 1,200 layers, damn near maxing out the machine's build height. This is also my first time printing with 3 materials, and before too awful long, I think I discovered what the nozzle might have crashed into earlier. As it turns out, rather than exiting through the chute, many of these poops are dragged into the print, becoming partially fused and thus potentially colliding with the hot end. So, on a hunch that maybe it was my container blocking the airflow or even the magnets somehow f***ing with the kinematics, I came up with this alternative, unfortunately to no improvement. So, as much as I'm willing to join the choir of those singing high praises for the machine's print quality, why am I also the only one reporting on this particular issue? Especially if every 20 or so layers, almost like clockwork, the filament is bound to pile up in the chute, causing the print to halt with an error message. This gives me anywhere between 30 minutes to a couple of hours of uninterrupted operation before I am invariably prompted to intervene, making sleep, of all things, a bit of a challenge. So, after 4 days of power naps, literally next to the machine, I observe it cross the finish line. This is just about the entire build volume of the X1C. There wasn't even a place for the wipe tower other than directly inside the print itself. Nevertheless, the amount of crap that didn't exit through the poop chute is a little concerning, as any single one of these could have struck the nozzle. On the flip side, none of them did, and the new support material proved quite effective. Certainly better than my one experience with water solubles. Anyway, let's go for another 100 hours, once again with me hovering over the machine, armed with a set of tweezers, keeping these things from knocking into the actual print, or at least being there to resume anytime the camera would detect an obstacle. Nevertheless, I would eventually require a few consecutive hours of rest, and this is where we get to see the machine run entirely unsupervised, a stunt which nearly cost me the print as something crashed into the supports, making the problem worse with each subsequent layer. Thankfully, I recovered it just in time for the leg to form, with the remaining couple of days spent doing pretty much this, so just imagine babysitting an entire print farm of these all running at once. That being said though, let's also acknowledge the fact that both halves finished on the first try, with the right underside of the battery compartment as the only defect potentially requiring a do-over, but we'll see about that later on. Here's all the crap that I've slept through, some of which seems a tad concerning, what with the solid lumps of plastic, as it's only by sheer luck that none of them crashed the print. And before I even get to removing the supports, with the FL Sun experience still fresh in mind, I just wanted to make sure that both halves printed to scale.
Oh, thank f***.
Indeed, the last thing that I'm looking forward to at this point is another 4 days of no sleep. And in saying this, I'm obviously not exaggerating. You've already seen what happens when I step away. Speaking of which, this little patch here ended up fusing, so sad face and so forth. Moving on. Up next is the back cover. Lots of little detail, and I'm printing it upright, with the layer lines in the same orientation as the rest of the print to avoid any stair-stepping along the smooth geometry. Once again, supervision is advised at all times. The print makes it up to here before we have a visible layer shift, and a short while later, one of the supports goes missing in action, so bail?
I think bail. Bail. Yep. Bail.
And just for perspective, this is not an easy print on any machine. I did, however, manage a remake with traditional supports, so here's a very impromptu Core XY versus Delta comparison, and if I could just keep shit from running into the print, I would actually prefer the Bambu Lab rendition. Nevertheless, the other print still serves a purpose, namely to ensure that I'm left with clearance after that entire wall came in the way it did. Thankfully, we're all good, otherwise this is all fused, so here's what I'll try on the X1-Carbon, and Yeah, that appears to have worked. I guess the strategy is to encase the print in a protective layer of this breakaway stuff, which I'm already reordering in pairs as these are only half spools. Either way, it works. For the most part, it all just comes off like that, so if you have a podcast or something to get through, this can actually be a relaxing way to pass the time. There's still plenty of spots where the little wisps of the support material are fused into the print, which, all things considered, is still better than contending with something like this. Up next, the chamber divider. Very easy, no problems, same with the little weights. Printed completely solid, these will add some extra mass to the Designer series passive radiators from Dayton Audio. And to reach my target response, I'll want to add exactly 8 grams. These attach like so and are set aside for later. My next challenge is to get these insets fitted with some brass. And I call it a challenge given that there's an entire market dedicated to heat set presses and specialized soldering tips, implying that you couldn't simply grab a regular one like this and push the little fuckers in from an arbitrary angle. But as it turns out, you totally can. It just takes a few extra seconds for it to heat. The drivers are lined with reusable adhesive, wired, seated into place, and bolted down with 6 and 4x8 screws. This is where Sophie shows up to spread some JB weld across the ledge, the chamber divider plops in, and if you should happen to have a spare Audio Dynamics 3000 Series 8 lying around, this is where you'll want to set that ass down for the next 12 to 24 hours. Afterwards, some more JB weld, this time into the groove connecting the two halves, and once those come together, we can set them aside to focus on the back cover. Right away, a couple of switches, one for power, one for illumination. As for the guts, a small Bluetooth amplifier, and a battery module. Needless to say, everything fits exactly as modeled, and here the M4x8 screws thread directly into the frame. What's more, between the acoustic design and the efficiency of these modern Class D amplifiers, I should be able to exceed the runtime of the JVC boombox with just 3 of these 18650 lithium-ion cells. Here, it's probably worth pointing out that the RVB550 would require 8 D cells and 3 AA's, or 5 if you count the ones in the remote. The power supply is external, no sense lugging that around, and once plugged in, the batteries are left to charge. This is where I get the rest of the threaded inserts into place, followed by a thick gasket of reusable adhesive, both on here and on the radiator itself, simply as I don't trust this particular basket design. Luckily, everything lines up, and once the radiator is mounted in, the outer grille attaches with just a pair of these M4x25 screws for the time being. Same thing on the opposite side, at which point we can finally take some readings and program the onboard DSP. Here's a signal chain I threw together in Sigma Studio, and for the initial sweep I'll pass everything through without processing. That being said, if there is one thing that I can appreciate about these passive radiators, it is their mechanical predictability. This is pretty much dead on, down to 50 Hz and all. What's more, a simple 3-point parametric EQ, along with a 50 Hz subsonic filter, is all that it takes for these $30 midwoofers to really get into character. So this is where I take the outer grills back off, and as an homage to the original RVB550, I attach some blue LED strips. These are self-adhesive, though just barely, hence all the contact cement, and running the power leads back to the electronics compartment couldn't be easier. Same thing at the other end, this time with all 4 screws keeping the grills in place. This just leaves the excess of wires, which I've shortened considerably, as the compartment that all this stuff fits into is very tight. That being said, with the last 4 screws holding it all in, we are ready for the finishing touch. Earlier on, I picked up some of this 2-inch wide polypropylene webbing and had Sophie make me a heat transfer logo to go directly in the middle of what would become the strap, giving it that branded look. I've also designed my own TriGlides for the simple fact that I wanted them in that specific orange, so here's a practical print for my practical print, though as you can see, even here the filament is inclined to stick to the nozzle. And while you can always just hit pause, sending the extruder to its little parking spot for some impromptu maintenance, once you go to resume, it simply pulls more filament in behind it. And this is really the crux of my love-hate relationship with this machine. On one hand, the prints come out absolutely amazing, but on the other, the sheer extent to which you have to intervene seems borderline incessant. At least in contrast to any printer where the only thing you have to check on is the filament roll, and even then maybe once every 12 to 24 hours. Anyway, this is it, the finished product. Here's the fancy motion control pan just for the comments asking,
Dude, how do you do that?
and here's Sophie all set for the final reveal, even though she's already seen all the stuff half assembled.
Alright, have a look.
Ooh, look at that. Oh, those came up nice. Look at that. Oh, that's too fucking cool. Oh, that's really cool. Okay, I love it. I love it already.
Alright, look around the back. See the two buttons?
Buttons.
The red button is your power button. So now
Good click.
it's going to pair to the computer there. Should have already done so. And it's literally as simple as the device that's controlling it issuing out the commands. So your volume is whatever the volume is on the device, and you can control it from the rotary encoder here on the number pad.
Gotcha.
Bring it to right around 70-ish, give or take.
70-ish.
And at this point is where you should be able to play some music, except for one more feature. If you look back there, there's a blue button as well, which does something else.
Blue button. Do I push the blue button?
How observant are you?
I'd like to assume that I'm observant.
Alright, push the button.
Pushing button. Apparently I'm not as observant. Oh! There it is! I couldn't see it.
And we'll put a little countdown until
That's fine.
Alright, go ahead.
Cool. And we start.
Yeah.
Okay. Cool. I'm gonna go further into this one. No, I like this piece. Whoa. So it doesn't go all the way down, but I can still hear, and it
Got
doesn't.
stuff at right around 50 hertz.
But it doesn't drop out. It doesn't sound like it's actually missing, but I know what I'm listening for. That's really nice. The highs on it aren't as tinny as I was expecting them to be either. Oh, that sounds so nice. Oh, that's so nice. And I really like how the strap came out.
Yeah.
See, that just sounds like it should. Ah!
Another thing
And I still get spacey with it like that.
emphasizing is that this entire demo is happening on battery power.
Oh yeah, it's not plugged into anything at all. Glorious. And it came out so nice. I'm gonna toot my own horn on that one. I made that.
What do you think?
Yeah.
Not that heavy either.
No? No? so cool.
So that's the YouTube safe demo out of the way, after which we adjourn to the office for some copyrighted content with the speaker chilling up there for the first couple of tracks, though quickly making its way down to ear level.
Oh, that's so nice.
Pause it for a minute. So now that you've gotten a chance to listen to all this music, what is your less rushed review of this?
Oh, I almost started crying. I really like how this turned out.
Over what?
Bad Fish by Sublime.
Oh.
I just absolutely love that man's voice, and it is extremely true to tone when it comes to male vocals specifically, because I just played a couple of different female vocals as well. And
Well, this thing is virtually flat from 50 hertz up.
And holy shit. Oh my god, I love it so much.
So, that's a free download if you're in the market for an entry-level, no-frills Bluetooth speaker. What's more, putting it together has certainly gotten me acquainted with the Bambu Lab ecosystem and the challenges that, if we go by any other review, either I'm the only one experiencing or I'm the only one discussing. The X1-Carbon is an impressive 3D printer to be sure. It's certainly the only one I've had that could do stuff like this. But if you've been sold on the idea that it just works, that obviously hasn't been my experience, so consider it for what it's worth. That being said though, many thanks go out to Bambu Lab for facilitating the acquaintance, and here's hoping that the future iterations of the system allow for a more hands-off experience. So, don't forget to rate the video as you see fit, subscribe if you're so inclined, and I'll see you in the next one. Cheers!